In this module, we are going to look at bar plots and histograms. But before we go into how we can use Matplotlib to plot a bar chart and histogram, I'm going to give distinction between both graphs. For bar plots, we use them to represent categorical or discrete data, where each bar typically represents a specific category or group. A typical use case is using bar charts to display the number of students in different grade levels. In this case, the category here is the grade levels, because they belong to certain grade levels, A, B, C, D, E, for instance, and then the number of students is the number of each student per the category. For histogram, we use them to represent the distribution of continuous data, such as numerical data or measurement data. A use case is using histogram to actually plot the distribution of the height of the students in a particular class. As we would see, there is a distinction between bar plots. Bar plots is for categorical data and histogram is for continuous data. Histogram can also show us the distribution of the data, like the central tendency. It can help us to know, like the data scientist, it can help us to know how widespread a data set is. It can help us to know if the data set is of a uniform distribution or skewed. Even for data analytics, this is also useful. Now, what I've done here is create a variable of categories. Let's say these are the categories of the grade levels of students, and the values here represent the number of students for each category. And to make a bar chart out of this, we use the plt.bar function, and we pass in the categories and the values. Here is like our X and our Y, and some other parameters like the color and the width of the bar, how wide we want it to be. And then, as we've seen in previous modules, the X label, the Y label, the title, and then the plt.show, which is very important. And that will correspond to what we have here. We can see that according to the category, it shows us the number of students that belong to each category. And as I mentioned, the width can be something that we would change. If we change the width, for instance, the value that we will see here is going to be different, because this is going to be not the value, but the shape is going to be more expanded. Now, if we want to plot our bar chart in an horizontal way, it's the same code except that we use the plt.bar h, which just means bar horizontal. The code remains the same. In this case, I've removed the width. However, everything else remains the same, and this is what our horizontal bar chart looks like. The choice to which one you would use in your own scenario depends on you. Now I'm going to show you an error bar chart. I've used NumPy to generate these numbers, and we are going to see what each of them looks like quickly. The X is just a list of numbers, as you would see. The Y is a list of numbers, as you would see. And the error, I've actually also generated that using NumPy. And the error is something that we can also quickly see, which is just some data points as well. One thing to note is that the number of items in X, the number of items in Y, and the numbers of items in E are all of the same length. To plot an error bar chart, we pass in the data point X, the Y, and we assign YERR to the error value, and then how we want the data points to be formatted in the bar. Let's see what that looks like.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
As we would see here, it shows us the error between each of the data points, and it just helps us see how far the values that we are trying to minimize, maybe some error from a model, for instance, how far they are from one another. You barely have to use an error bar as a data analyst, but maybe as a data scientist, you will find yourself plotting errors between the actual values of your model prediction and the predicted value. Next, we'll look at stacked bar charts. A very good example or use case of a stacked bar chart is when we want to display perhaps the percentage of survey respondents who enjoy different types of activities, and each person can choose multiple activities, and we just want to stack them on top of one another because there are multiple activities, but we want to put the different survey that people are giving regards their most preferred activity using the stacked bar. For the stacked bar, I have created two lists, A and B. And what I have done is to then get the number of the items so that I can use that to actually plot the stacked bar. So let's run this and I'll quickly show you what Z looks like. So it tells us that the range is between 0 to 4 because we have 4 elements here. And then for each of the stacked bar, to get the stacked bar, we pass in the very first bar and the second bar in the same cell, and we specify the one that we want at bottom. For example, we want the A list to be at the bottom. And we can see that here, if we look at the third element, which is 45, or the second one, which is 30, we see that the blue ends at 30. If we want to switch it, we can actually add the bottom to the A bar. And this is how you show a stacked bar. Stacked bar are rarely used, but sometimes you find yourself using it in cases like the one I mentioned earlier. How do we create an histogram? Here I have basically used NumPy to just create some data points. I'm going to show us what the data point looks like. I do not want to spend so much time explaining the NumPy functions as this course is not focused on that, but what I've done is just created some bunch of numbers, random numbers, using the NumPy function. And to create an histogram, we basically use the function plt.hist and we pass in the data. Remember that the histogram works to visualize the distribution of continuous data. So in this case, it's not like bar charts where we need to pass the categories and then the numbers that belong to each category. This time around, we are representing continuous data, which is just one-dimensional, and that is what we have done here by passing in data into the histogram. And then we can specify the number of bins that we want according to how distributed the data is, the color, and also alpha. These are just designed. The alpha just reduces the opacity of the blue color. If I remove it, for instance, we'll see that the blue is much more deeper, as we see here. And also we add the title as we've known before, the X label, the Y label, and then we show the histogram. And as you see, it shows us distribution of these data points. If we want to make the bin to be smaller, we can actually increase the size, and you will see that it shows us the distribution of this data. Next, we are going to look at pie charts and box plots.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.